Okay, we're going to start today by talking about segments and congruence. The first thing that we need to know is this word postulate right here. Okay, a postulate or axiom is a rule that is accepted without proof. We're going to talk about a lot of different types of postulates in this year, and it's all just math rules. Okay. The first one we're going to look at is called the ruler postulate. Now you see we have a number line right here. And these numbers here at the bottom are representing coordinates. They're going to be locations that our points are at. So let's say we have point A right here, we have point B right here, C is at 0, and then down here we have D at 2. Now, the reason that we need those numbers is for the location. What we're going to be talking about today is how to find the length of segments and the distance between points. So let's say that we wanted segment AC. AC right here. Okay, this is the segment that we want to look at first. We can count the actual spaces in between them. That's one way to get the length of AC. Or we can use a formula if we need to. So let's go ahead and just look at counting the spaces. When we do this, you're not counting this first hash. That's not a distance right there. That's your starting point. So we have this space, so there's 1, this space, 2, and this last one right here, 3. So the length of AC, okay, let's get this written, AC is 3. Now notice on this, I did not put a bar across the top. When we are talking about length of a segment, you don't have to put the bar across the top. That's one way we know that's what they're looking for instead of a different name for that same segment. So if you do not see a bar across the top, they're wanting the length, the distance between them. Okay? Now let's say our number line isn't like this one. Let's say it's going by from negative 100 all the way to 100, and you have really big distances that you're trying to get the in-between value of. If that happens, it would be easier to do a formula. And for this case, what we're going to do, we need to do the absolute value of one of our coordinates. So we're going to say x2 minus the other coordinate, we'll say x1, and we're taking the absolute value. Do you remember what that is from algebra? Absolute value. Whatever goes in comes out positive. So when we're dealing with length or distance, we have to have a positive value. So that's why we got to make sure and have this. So we're going to take, let's see, our first one, let's say is at 0. So we're doing the absolute value of 0 minus, and our second location was negative 3. So minus negative 3. Okay, now thinking back to algebra, minus minus is a plus plus. So 0 plus 3 is 3. So either way, you're going to get the right answer. But if you have that number line that's using really big numbers, it would probably be easier to do this formula. When 3 points are collinear, one point is between the other two. Now here's what this is saying. Let's say we have our 3 collinear points. We got, ooh, that's an ugly point. We have A, B, and C. Okay, you can see they're all lined up together. They are collinear, but because they are collinear, B has to be somewhere between the other two. Now, if we had a point over here, let's say we have point D, we cannot say D is between A and C because it is not collinear with these 3 points right here. Down here at the bottom, we're going to talk about the segment addition postulate. This is my favorite postulate that we have. And what it happens here, we're going to have a segment. It's not always on a line. Let's say we got A, B, and C. Okay, we are focusing on segment AC, okay? Now what this postulate is telling us is that this little piece and this little piece, BC, is going to make the whole segment. So little piece plus little piece equals the whole big piece. Now they're going to throw numbers in there. So they could say like this piece is 3 and this piece right over here is going to be 6. So that would make the whole segment 9. They also like to give you problems where you know the whole segment. So let's say we have this one right here. We got T, W, and U. Okay, and they're going to tell you the whole segment TU is 20. And they're going to tell you this piece right here, TW, is 8. So they're wanting you to find this last missing piece. Now we know from that segment addition postulate that the little piece plus little piece equals the whole big piece right here. So 8 plus something is going to give us 20. How big is this segment right here? It's got to add up to 20, so WU is going to be 12. Congruent segments are line segments that have the same length. Now, what you may see, let's say we have these two parts, and they want to say that these two sides are equal. So what they're going to do is put a congruent little tick mark here to let you know that they are congruent. It should just be 1. Come on, just make 1. Having a little trouble with my pen. Okay. And we could say that these two pieces are equal. So let's say we got D, E, F. So we could say the lengths of DE and EF are equal, and we could say the segments are congruent. And our congruent symbol is an equal sign with a wave above the top. So this is our congruent symbol.